Aromatic hydrocarbons are hydrocarbons that contain a benzene ring. And a benzene ring is a 6-carbon ring that's going to have alternating single and double bonds, as is seen here. Now, in looking at this structure, you might say, well, can't we have the single bonds and the double bonds moved around? And the answer is, we can indeed. That will produce similar structures, such as this one seen here. You have an identical setup. It's basically like you rotated the original structure 30 degrees either direction, but each of these are equivalent structures, and so the fact that those double bonds can basically float from one carbon to another, still maintaining the alternating single bond double bond arrangement, gives rise to what we call resonance structures, or resonance formulas. And in general, the more resonance formulas a compound has, the more stable it is. And so your aromatic compounds, the ones that contain benzene, even though benzene has 3 double bonds, and double bonds are usually very reactive, benzene is a fairly stable compound. And so your aromatic hydrocarbons have a good deal of stability when it comes to this portion of their molecular structure, the part that deals with the benzene ring. You get resonance where you have delocalization of your electrons. If you were to envision the pi bonds, those pi electrons, in each of those pi bonds surrounding that 6-membered ring of benzene, you would see that you actually have an unhybridized p orbital on each of the 6 carbons. And so you could very easily have sideways overlapping between any of those 2 adjacent p orbitals, which gives rise to the 2 different structures that we saw. The greater the resonance, the greater the stability of your compound. When we name these aromatic compounds, these benzene-containing compounds, we can name them one of 2 ways. First of all, we can name them as if benzene is the parent group. And usually you'll do this if you have multiple carbon groups or other functional groups coming off of a benzene ring. So you have multiple points of attachment to the benzene ring. In order to name it, you would name the substituents just as you do with cycloalkanes. Name them position number if there's multiple substituents. Name them in order of alphabetical order by the substituent name. And this time the name is going to end with benzene. Benzene can also be treated as a substituent group, and usually this is the case if you have a long linear parent chain, or if you have a benzene ring that is attached to a carbon chain and it's attached somewhere in the middle of that chain, and that's the only attachment it makes. We name benzene as a substituent in that case because, at least at this point, naming a substituent hydrocarbon group where it attaches in the middle of the chain gets into a little more than just naming how many carbons are in the substituent. You actually have to add a prefix to indicate how that attachment is taking place, whether it's on a secondary or a tertiary carbon of the substituent. We're not going to quite get into that at this point. But anyway, getting back to benzene being treated as a substituent, its name then becomes phenyl, P-H-E-N-Y-L, and that's important to note. It'll be more important later when we talk about alcohol functional groups. But benzene as a substituent would be known as phenyl, and you use the same naming conventions that we've talked about for naming substituents for alkanes, alkenes, alkynes. So if we take a look at some examples here, remember that one of the standard notations for benzene is a hexagon, and because of that delocalization of those electrons and the fact that you could put those double bonds pretty much anywhere and have that repeating double bond, single bond, double bond, single bond, double bond, single bond arrangement, the standard notation for benzene is a hexagon with a circle inside of it. And so for each of these three compounds, we have benzene as the parent chain, or the parent group, and then a substituent or more than one substituent coming off of it. So in the first one, we have one single substituent, so we could name the position number, but it's not absolutely necessary. It's a 1-carbon substituent, so this would be a methyl group. And so we would name this methylbenzene. Now methylbenzene also has a common name, and its common name is toluene. Please take a moment and pause the presentation. Try and name the two remaining structures, and then resume the presentation. In the second example, we have benzene as a parent group, and we have a 2-carbon substituent, which would be an ethyl group. Again, there's only one substituent, so the position number of the ethyl group is not really essential, although you could put it in. And the name of this one would be ethyl benzene. In the last example, we have 2 substituents off the benzene ring, and so position numbers are necessary. Priority for carbon numbering on the benzene ring rests with the ethyl group because it's larger than the methyl group, has a higher priority. And so the name of this last compound would be 1-ethyl 2-methyl benzene.